with working with ellipses. And one of the things that you're going to have to do when you work with an ellipse is you're going to have to try and factor stuff all the way down into a factored form of some quantity squared. It's going to have a shape where inside an ellipse you're going to have like x minus 3 squared over 4 plus y minus 7 squared over 16 equals 1. This is your ellipse shape. Well, to work with your ellipses, what you're going to have to do sometimes is factor. And when you factor, things aren't going to always look so pretty. You're going to have to complete the square. And we're just going to practice that real quick before we get into ellipses. So if you are completing the square and you're given an equation that looks like this and they ask for an ellipse, well, what we'll want to do is get this into a factored form. So rewrite the equation by putting together all your x's. So we'll put this guy together with this guy, and all your y's, which would be this guy and this guy. And don't worry about that 11 right now. That negative 11, he'll show up later. So what we're going to have is we're going to have 9x squared minus 18x plus 4y squared plus 16y, and then minus 11 equals 0. So we're going to complete the square from here. And in order to complete the square, the leading term that we're going to look at is the squared term, and we've got two of those, an x squared and a y squared. And it has to have a coefficient of 1. This guy right here has a 9, so if we pull that 9 out, that gives us x squared minus 2x. And I'm going to write a plus here. And we're going to do the same thing with the y. We're going to go ahead and pull that 4 out, and that will give us y squared plus 4y. And again, I'm going to write a plus. And the reason I'm going to put those pluses in is that's where the completing the square part is going to show up. And on the other side of the equal sign, we're going to have two blanks. And actually, we're going to have, let me put them in the colors they're going to match. We're going to have a purple blank, and we're going to have a green one. And when you complete the square, there's just a little mantra you can say to yourself. Half it, square it, add it, darn it. Okay. So when you're looking at this purple guy, what's the half term is this middle piece right here. That's the half part. So half of negative 2 squared is 1. Okay. And then the add part comes right here. This is 9 times 1. Okay. There's your half it, square it, add it, darn it. And then on the other side, my half of 4 is 2, squared is 4. So now that's going to be 4 times 4, that's 16. So half it, square it, add it, darn it. And what you're going to end up with then is 9 times, and this purple guy factors to x minus 1 squared plus 4 times y plus 2 squared. And when you get to the half it part, that's what you will always factor down to. I'll go ahead and add the 11 to the other side here. So what I'm going to end up with is 25 plus 11. And in order to get this shape, you know, I'm gonna need a 1 on the right. And we won't worry too much about it here because we haven't learned a whole lot yet about ellipses, but this is kind of what we're going for. So if we were working out our ellipse and trying to get an equation, we need to be able to get to this point right here. And once we get to that point right there, life gets really nice, and we can divide both sides by the 36 because that's what's going to make a 1. So we'll divide everything by 36. Okay, and this is going to give us x minus 1 squared over 4 plus y plus 2 squared over 6 equals 1, squared over 9 actually. Okay, and this is how you're going to use completing the square with an ellipse. You're going to follow this process right here. And then what we'll do from here is look at several examples of ellipses, what an ellipse looks like, the things that we need to know. But this is a really important process right here, completing the square. All right, so here's what an ellipse looks like. It's the red shape there. It's an oval. Most people refer to it as an oval. And it's got several things that are really important on it. It's got a center, which is right here in the very middle. It's got a vertex, which is the vertex is located at the end of the long stretch of the ellipse, which is the major axis. It's got a covertex, which is located at the ends of the minor axis of the shorter one. So we've got a major axis and a minor axis. The major axis is really, really long. The minor axis isn't. And then there's these two green points right here. It's called a focus. And those green points are what the ellipse bends itself around. So this is how your ellipse would look, centered at the origin, and we might call this the x-axis and the y-axis. Okay, and so what you're going to do then, when you work with an ellipse, is you're going to work with an equation that looks like centered at the origin. Centered at the origin, it's going to look like x squared over a squared plus y squared over b squared equals 1. Or and that's going to, this one will give us a shape like what we have right here. Okay. If you have x squared over b squared plus y squared over a squared equals 1, this is going to give us an ellipse that has a shape where you are stretched along the y-axis. Okay, so if that first number is smaller, you're going to stretch up and down. If the first number is larger, you're going to stretch left and right. And if you're not centered at the origin, if you're centered at the point H and K, then you're going to follow these two patterns down here. And again, this one is going to be just like the guy that we've got graphed right here, except moved off of the origin. And this guy then is going to be of the variety stretched up and down. So this guy would look, you know, something like, if we're centered at HK, he would look something like this with his center right there. So these are your equations for ellipses. They're very important equations. You can use them in a lot of different ways to get a lot of information. But some things that we need to understand is this value for A and B. The A value is the distance from the vertex to the center. That is always going to be A. So it doesn't matter if you stretch left and right or up and down. The distance from the vertex to the center is A. The other distance that's really important is this minor guy. Okay, and this is the distance for B. Okay, from the center to the covertex. That's going to be the B value. And then the very last one is the C value. And the C value is the distance from the center to the focus. That's going to be your C. And so these three things are related together, and they're related together in such a way that they give us this ellipse. And if you relate A, B, and C in different ways, you can get different conic sections. So this is what an ellipse looks like. And we'll look at some examples of how to work with these numbers on the next slide. Okay, so what we're looking at then with this slide is graphing an ellipse. And remember that A is the distance from center to vertex, center to vertex. And that's the long side. Okay, that's on that major axis. Okay. B is from center to covertex. And that covertex is that minor axis. And the center is going to be based on these 2 points right here. The two will represent our x coordinates and the 3 will represent our y. And if you're working with conic sections, one way that can help you remember where to go is if you think about the super secret opposite society. And the super secret opposite society works with conic sections. It's a great thing. It'll help you remember that the 2 is actually negative and the 3 is actually positive. So our ellipse is centered at this point right here, the point -2, 3. Okay, and then we want to find A and B, because once we know what A and B are, we can stretch our ellipse out and graph it. So A is the square root of 16, which is 4, and B is the square root of 25, which is 5. Now, look at these guys, and let's think about what we saw in the previous slide. If I go up 5, I'm going to actually have my major vertex. So for this particular problem, the A is the bigger number. So A is 5 and B is 4. Okay, and so I'm going to move up 1, 2, 3, 4, 5. Let me change ink here. So here's my 5 and then down 5. 1, 2, 3, 4, 5. This is my major vertex, or my major axis. My vertices are these purple points. Those are my A values. My co-vertices are going to be the 4 to the left and right from the center. 1, 2, 3, 4. And then the other way. 1, 2, 3, 4. And then what I'm going to do is just connect these guys together to get my ellipse. And it needs to be curvy. Ellipses are not pointy. That was not a very pretty curve. Oof, this is one ugly ellipse, but no points on that sucker. So here's your ellipse right here, and that's how easy they are to draw if you're given the equation of an ellipse in this vertex form, in this center form. Well, what about this guy? How do we graph him? This is exactly like our opening problem. What we have to do is complete the square and rewrite this equation in a form that works for us in that standard form. And a standard form is just so nice. It's vertex form for a parabola. And so that's where you've seen a little bit of it before. So basically what we're going to do is rewrite this guy and put the x's together in the front. So I'm going to have 9x squared minus 18x plus 4y squared plus 16y. And I'm going to go ahead and move the 11 over to the other side. Now, we've seen this just a second ago, so let's see if we can get to the same numbers that we got. I'm going to factor out that 9 in front of x squared because I need it to just be a plain x squared. And I'm going to factor out a 4 because I just need plain y squared. Just one y squared. Okay. And half it, square it, add it, darn it. And so when I take half of this middle term, this is where we're halving, is this guy right here. So when I half that guy, I get -1 squared is 1. And then half of 4 is 2, squared is 4. And so I'm going to end up with 9 times x minus 1 squared plus 4 times x plus 2 squared equals, what is that, 16? Oh, 4 and 1. Let's see, this needs to be 9 and 16. Why is it 9 and 16? I made a rookie mistake there, a death by 1,000 cuts mistake. Remember that when I put this 1 here, this is 9 times 1, and 9 times 1 is 9. and 4 times 4 is 16. So I'm actually adding uh, those guys together. So this is going to be 36. And then divide both sides by the 36. And when you divide, remember you divide by every single thing. So I end up with x minus 1 squared over 4 plus x plus 2 squared over 9 equals 1. And remember that a is the bigger number, so this guy's going to be 3 for a, and b is going to be 2. And the center is the super secret opposite society, so my center is going to be at 1, negative 2. So I can go to 1, negative 2, put my center down, and then this is going to stretch up and down because the larger number's under y. It's going to stretch up 3. It's going to stretch down 3. It's going to stretch to the left and right 2. And then when you connect these guys, I'll see if I can do a better job here. You get an ellipse. Okay, so we want to write an equation of an ellipse with foci of 1, negative 4 and 5, negative 4 with major axis endpoints that are at 0, negative 4 and 6, negative 4. So what I would recommend real quick is just sketching that guy out a little. Just get a rough idea of how it looks. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Again, we don't need to sketch out the whole graph. We just have to get an eyeball on what this thing's doing. And we're at the point 0, negative 4 here, and 6, negative 4 here. These are our endpoints for our major vertices. And then the foci are at 1, negative 4. So 1, negative 4. There's one focus, and 5, negative 4. There's the other focus right there. And so using this information, we want to come up with an equation that gives us our ellipse. And one of the things that we have talked about just briefly is this guy right here, the foci. And the foci is that distance c from the center, okay? The distance c from the center. So if we're looking at ellipses, the way that we can relate a, b, and c is with this guy right here. C squared equals a squared minus b squared. That relates all of them together. And so what we'll do is we'll try and plug in what we know to find what we don't. Okay? Now, the first thing that I need to have is the center. And the center is the right in between, the halfway point of all of these guys over here. So this halfway point, somewhere right around in here. Okay? And wherever that halfway point is, that's the center. Well, I know for a fact that my center has to have a y-coordinate of negative 4. And I know that because negative 4 is the y-coordinate on all the points that I've looked at so far. Okay? Because these are all major axis points. So I just need to get to the middle of that. So what's halfway between 0 and 6? Well, 6 minus 0 divided by 2 is 3. So my center is at the point 3, negative 4. Okay. Now, what about my a value then? Well, the a value is the distance from the center to the vertex. And in this case, that's going to be 3. Okay. What about my b value? B, I don't know. Well, what about the c value, the distance from the center to the focus? Well, if my center is at the point 3, negative 4, and I move from this point right here, let's see, let's make it big, from this point right here, 3, negative 4, and I move to a focus, I move from 3 to 4, from 4 to 5, so I'm moving 2 units. That's my c value. Well, how can I find the missing b value then? I can just use my relation that I've got up here in blue. So I'm going to have 4 equals 9 minus b squared. Subtract 9 from both sides. and divide both sides by -1. And so I get that b is going to be the square root of 5. No problem. Remember, if I'm going to write an equation, I'm going to have x minus the x coordinate for the center squared over a squared plus y minus the y coordinate for the center squared over b squared equals 1. And I've got all of that information. And notice that this ellipse is going to have a shape that's stretched left and right, which means the larger number goes under x. So what is my equation going to look like? It's going to look like x minus the x coordinate for the center, which is 3, divided by the larger number, which is bigger, 3 or the square root of 5, and it's 3, plus y minus the y coordinate, y minus -4 is +4, and then the square root of 5 squared is 5. And so there is my equation for this problem. And really, it doesn't take just a real rough sketch and to get an idea, and then some math, and you're good. So now we're looking at writing an equation of an ellipse with a major axis at endpoints -5, 2, and 3, 2, and a minor axis that should be length of 6. So A, we don't know. C, we don't know. B, we don't know. And the center, we don't know. So let's look at a real rough sketch just to get an idea of what this is going to look like. Okay, I'm at 5, 2, -5, 2, 2, 3, 4, 5, 2. And I'm at 3, 2, 1, 2, 3, 2. Okay, so here's my vertices, and the center is halfway between these two guys right here. And notice that my center is going to have a y coordinate of 2 because both of my vertices have a y coordinate of 2. And so let's do stop, which is 3, minus the start, which is -5, divided by 2. And this is going to give me 3 plus 5, which is 8 divided by 2, which is 4. 4 is going to be the halfway distance between -5 and 3. So I'm going to move 4 units. 1, 2, 3, 4. So here's my middle right here at the point -1, 2. By the way, I was able to figure out my A value, 4. So I'll go ahead and fill him in. And then it says that the minor axis length is 6. Well, remember, the minor axis, the whole length of the minor axis is going to be 6 units long. So that means it's got to be the same number of units on top as it is on bottom. Well, if this whole guy right here is 6, then the halfway point has to be 3 up and 3 down. And so if we're 3 on the top and 3 on the bottom to my vertices, then my B value has to be 3. And now I can write the equation. It's going to be x minus the x coordinate squared over, and this guy stretches left and right, so which number is bigger, 4 or 3? And then y minus the y coordinate, and there's your equation. Remember, the general equation you're going to have on the bottom, this is going to be a squared and b squared. So whatever numbers we have in the a and b spots get squared so that we can complete this. Okay, lastly, we want to look at using an equation of an ellipse to determine some different things. And that's the center, the foci, the length of the major axis, the length of the minor axis for each ellipse. So the center is always one of the easiest things to do. and it's just the super secret opposite society. So the opposite of -3 and the opposite of -5. Okay, the a value is the square root of the bigger number. So the a value here is 5, and the b value is 4. Okay, so when they ask us to find the foci, which is the c, so we need to find the points where the foci are, then we just need to figure out how far we are from the center. And on a previous slide, we had that c squared was equal to a squared minus b squared. So 25 minus 16, the square root of that will give me c. And 25 minus 16 is 9, square rooted is 3. Okay, that's my value for c. This ellipse is going to, if you look at a real rough sketch, I'm at 3, 5 for my center. I go 5 units one way, 4 units the other. I stretch like this, left and right. And so my C value, the only thing that's going to change is X, because my focus is going to have a point that has a Y value with a 5. So how can I find my focus? I'm going to do the center coordinate here, 3. And then to find the focus, for one focus, I'm going to add 3. And to find my other focus, I'm going to subtract 3. That takes me in both directions away from the center, both to the right and the left. So my focus has a point of 6, 5 and 0, 5. Okay. The other thing that we want to find is the major axis and the minor axis. So the major axis is the distance from the center to the vertex, and we go from the center to each vertex. So if we do that both directions, we're going to have 5 plus 5, which is 10. And then the minor axis goes from the center to the covertex, and we're going to do that. It'll be 4 plus 4, which is 8. And so that's the length for both of those guys. Down here on the last one, again, let's look at a real rough sketch. We're centered at -1, 2, and we're stretching this way, up and down. How do I know that? I know that because the y, the number under the y is larger. So my center is at the point -1, 2. My a value is 6. My b value is 3. My c value then is the square root of a squared minus b squared. So 36 minus 9 is 27. And so just like we saw up on the top problem, when I go for finding my foci, I need to start at the middle, but this time the only value that's changing is the y value because we stretch up and down. And how much do we stretch to get to the focus? We stretch up to the square root of 27, and we stretch down to the square root of 27. So we would say plus or minus the square root of 27. That gives me my focus. My major axis is the axis from the center to the vertex. We count it going up and down from the center. So we get 6 twice, which is 12. And my minor vertex goes left and right from the center, and that distance is b. And so when we count b going to the left and b going to the right, we get 6.